If self-driving cars are ever going to be a real part of our daily lives, they have to conquer the one thing that even messes up human drivers: really bad weather. Trying to navigate safely through a downpour or a snowstorm is one of the biggest hurdles in the whole industry. So today, let's dig into a really cool engineering breakthrough that's aiming to give these cars superhuman vision, especially when ours isn't cutting it.
So let's just ask the big question right up front. How on earth does a car see the road in the middle of a blizzard? We're talking about life and death decisions that depend entirely on its sensors. But here's the thing, not all sensors are created equal, especially when the weather gets ugly. And that is the central puzzle that researchers are working around the clock to solve.
To see the world, these cars use a few different tools. You've got cameras, of course. Then there's LiDAR, which uses lasers for these incredibly detailed 3D maps. But when it starts to rain or snow, that light gets scattered and confused. But then you've got 4D radar. It just cuts right through all that interference. It is the undisputed all-weather champion, and it's really the key to unlocking true drive anywhere, anytime autonomy.
Okay, so if 4D radar is this miracle sensor, what's the catch? Why isn't this problem already solved? Well, it turns out that while the sensor itself is incredibly powerful, the raw data it spits out is a mess. It's what engineers call noisy. So just having a great sensor isn't enough. You have to be able to make sense of all those chaotic signals.
The old way of dealing with all this noise was, let's be honest, pretty clumsy. A system would look at all the incoming radar data, find the strongest few percent of signals, and just toss the rest in the garbage. But that's a terrible strategy. See, radar signals naturally get weaker the farther they travel, so this simple-minded approach was constantly throwing away crucial data about cars and obstacles way down the road. The very things you need to see most.
So what is all this noise we're talking about? Well, it's not just one thing. It's really three main culprits working together. You've got your basic background noise that's always there. You've got interference from other cars' radar systems, and then you have clutter, which is just unwanted reflections bouncing off things like the road, guardrails, or even the raindrops themselves. The car's brain has to somehow sift through all of that junk to find what's actually real.
To solve this, the researchers behind a new system called RTNH Plus created something way more intelligent. This is their first big innovation. They call it CCTP, and it's basically a much smarter sieve for cleaning up that messy radar data.
Think of CCT like a two-stage cleaning process. Instead of one really aggressive filter that might accidentally throw away good data, it uses two different levels of filtering. First, it does a coarse pass to get rid of the obvious garbage. Then it uses a much finer, more careful pass to isolate only the most reliable signals. It's a deep clean that doesn't lose the important details.
And how it does this is actually really clever. In step 1, that coarse filter keeps everything that might be a real object. Then in step 2, a more precise filter zeroes in on the most definite high-confidence signals. But here's the genius part. In step 3, it then looks at those definite signals and goes back to recover their immediate neighbors, correctly assuming they're all part of the same object. It's a way of cleaning everything up while smartly putting the complete picture of an object back together.
Okay, so now the data is clean. That's a huge step. But just seeing a bunch of clean data points isn't enough. The system has to understand what it's looking at in 3 dimensions. And this brings us to the second key innovation, an algorithm called vertical encoding, or VE for short.
Before this, a lot of systems handled 3D data in a really inefficient way. They would take this rich, beautiful 3D point cloud from the sensors and just squash it, flatten it into a 2D map. This meant you lost all the crucial information about height. You couldn't tell the difference between a flat manhole cover on the road and a tall pedestrian standing on it. The new way, vertical encoding, cleverly holds on to that essential third dimension. I want you to think of VE like a talented sketch artist. They don't need to draw every single eyelash and pore to capture what a person looks like, right? They just need the key outlines. VE does the same thing. It quickly identifies the most important features, the top of an object, the bottom, the key vertical lines. This gives the AI all the information it needs to understand an object's 3D shape, and it does it in a way that's both incredibly smart and super fast.
So we have a smarter filter and a more efficient way to see in 3D. It all sounds great on paper, but how does this new RTNH Plus system actually perform when you put it to the test? Well, let's take a look at the results. The answer is, it works. It works really well. On a standard test for detecting objects in 3D, RTNN Plus beat the previous version by over 10%. Now let me tell you,
In AI research, a double-digit leap like that is a massive deal. That's a huge improvement.
But check this out. When they made the test even harder, demanding a much higher level of precision, the performance gap grew to an incredible 16%. This tells us the system isn't just finding more objects, it's pinpointing their exact location in space with way more accuracy.
You don't even have to be a data scientist to see what's going on here. The raw numbers just tell the whole story. Across both the standard test and the really tough one, this new system with its two big innovations isn't just a small step forward, it's a giant leap in performance.
At the end of the day, this isn't just about abstract numbers on a chart or some cool new algorithm. This research is a real, tangible step toward a future where our transportation is safer and more reliable for every single one of us, no matter what the weather forecast says.
And as if all that wasn't enough, the team did something else that's just awesome. While they were working, they discovered that over 25% of the object labels in the public dataset they were using were just plain wrong. So they manually went through and corrected them. This doesn't just help their own project, it cleans up the data for the entire research community. It's a classic case of a rising tide lifting all boats.
So what we have here is a huge step forward in perception, a car's basic ability to see the world around it. But it also perfectly sets up the next great challenge. We've given the car better eyes, maybe the best eyes it's ever had for seeing in a storm. And that just leads to the next massive question. Now that cars can see this much better in any weather, can they learn to think better?